Okay. So oblique asymptotes. So function has an oblique asymptote only when the degree of p of x is greater than the degree of q of x by exactly 1. So let's say you have function f of x equals p of x over q of x. Okay. If the degree of p of x is 1 more than the degree of q of x, or if the degree of numerator is 1 more than the degree of denominator, you have an oblique asymptote. How do you get the equation of the oblique asymptote? So when you divide the numerator by denominator, the quotient gives you the oblique asymptote. Okay, so let's look at the first example. So we have f of x equals x squared plus 3. It says it has an oblique asymptote. Yeah, because the degree of numerator is 2. Degree of denominator is 1. So this is 1 more than this one, right? The degree. Then find the equation of the asymptote. So we are going to do the division. When you are dividing, again, if the denominator has a degree of 1, you can use long division or synthetic division. But if the degree of denominator is more than 1, then you have to use long division, okay? So this is degree 1, so we can use the synthetic division. So we are missing here 0x, right? So we missed the term with x. So we can put it as 0x. Then you get 1, 0, and 3. On the left, okay, so whatever makes denominator 0, right? So which is 1. Then we do the division. So 1 goes down, 1 times 1, 1. 0 plus 1, 1. 1 times 1, 1. We get 4 here. So obviously we expected to see not a non-zero number here, because if we get 0 for remainder here, this means that x minus 1 is a factor of numerator as well. Then if you have x minus 1 and x minus 1 in numerator and denominator, means that there's a whole at x equals 1. Okay. So if you don't have a whole, means that, you know, this x minus 1 is not a factor of the numerator, and then therefore you should not be getting 0 for the remainder here. So this is the remainder. And actually, we are not interested in the remainder. It is not helping us, okay? So we are only interested in the quotient. This gives you then y equals x plus 1, and that is your oblique asymptote. So based on that, let's look at the other examples. Sketch a graph of the following functions. Okay, so we have x squared plus 3x plus 2 over x minus 1. So like any other function, we are going to find x-intercepts, y-intercept, vertical asymptotes, and then horizontal or oblique asymptote. In this case, as you see, the degree of numerator is 2 and degree of denominator is 1. So therefore, we will have an oblique asymptote. Okay, so x-intercept. So you have to factor. So this gives you x plus 2, x plus 1 over x minus 1. So zeros of the numerator will give you x-intercepts. So you have -2 and -1. Y-intercept. We substitute 0 for x. If you do, this will disappear. So you get 2 over -1. So that is -2. Y-intercept. Vertical asymptote. Zeros of the denominator. In this case, 1. So x equals 1 is the equation of the vertical asymptote. Now we are going to look at or find oblique asymptote. So we are going to divide numerator by denominator. Again, denominator is degree 1, so we can use synthetic division. 1, 3, 2. On the left, we have 1. Okay, so 1 times 1, 1, 4, 4, and 6. Again, this 6 is remainder, and we don't need that information. Okay, we are not using it. We will just use this quotient. Okay, So then y equals x plus 4 is the oblique asymptote. Okay. Then we can place this information on the grid. So we have vertical asymptote at x equals 1. We have an oblique asymptote, which is y equals x plus 4. So we're going to sketch that one. So y-intercept is 4, slope is 1. So 4, slope 1. Also, when you are sketching oblique asymptote, make sure you find the x-intercepts as well, okay? So x-intercept of this line would be negative 4. So this line is y equals x plus 4, which is your oblique asymptote. Okay, so let's put the points now. We have x-intercepts, negative 2, negative 1. And we have y-intercept, negative 2. Okay, so you can try to sketch it without even doing the factor table, okay? So let's look at the left side of the vertical asymptote. So what are the possibilities here? You can either sketch something here. Okay, it's going to look like, let me do it here. Okay, so if these are your asymptotes. So either when you're sketching like this, okay, or this with the asymptotes. Or here, let's say left side, you're going to sketch either here or there. Okay, let's say here, or for this one, here. You can't sketch here and here, then that would not be a function. Yes, it does matter. Okay, so now, having said that, without doing the factor table, I'm going to do it anyway, but I just want to show that it will work without the factor table, okay? So I see that, on the left side, either I will sketch it here or here, okay? If I sketch it here, then I need an x-intercept, but I don't have any x-intercept on this side. So I cannot pass through and approach the oblique asymptote if I sketch it here. So it looks like I will have to do it right here, and I have to pass through those x-intercepts and y-intercept. Okay, so it looks like that's gonna be right here. On the right side, again, we have two options, right? One is here, the other one is there. But if I do it here, I will have to pass through the x-axis. But I don't have any x-intercept on this side. I cannot just make up x-intercepts as I wish. So it means that I cannot draw it here. Therefore, it has to be there. Up there. Okay. So now, if you do the factor table, so we already sketched it, okay? So we don't even need the factor table, but I just want to confirm, okay, to show you. Negative 2, negative 1, and 1. We have the factors x plus 2, x plus 1, and x minus 1. Negative, positive, positive, positive. Negative, negative, positive, positive. Negative, 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 positive. Okay, so what do we have? Negative, positive, negative, positive. So when x is less than negative 2, function is negative, right? That is for f of x. So yes, when x is less than negative 2, function below the x-axis. Between negative 2 and negative 1, function is positive. It is between negative 2 and negative 1, as you see, function is positive. Negative 1 and 1, negative 1 and 1, function is negative. Yes, it is negative below the x-axis. When x is greater than 1, as you see, it is all positive here. So this kind of confirms. So now let's look at B. Okay. So of course we factor it first. So we have x cubed over x minus 2 times x plus 1. Again, we need the same kind of information. So x-intercepts, y-intercept, vertical asymptotes. And in this case, degree of numerator is 3 and degree of denominator is 2. So again, degree of numerator is 1 more than the degree of denominator. Therefore, you have an oblique asymptote. Okay. So x-intercepts. Let's start with that. So zeros of the numerator. Zeros of the numerator, x equals 0. So you get 0, 0. Y-intercept, you substitute 0 for x, you get 0 over a number. So again, y-intercept is the same thing. Vertical asymptote, x equals 2, x equals negative 1. X equals 2 and x equals negative 1. Oblique asymptote. Okay, so now we see that denominator is not degree 1. Therefore, you cannot use synthetic division. Okay, so you have to do the long division. All right, so we have x cubed and nothing else. So you have to fill it with zeros. 0x squared plus 0x plus 0. And denominator, don't use the factored form, of course. So you have to use the standard form. Okay, so x squared minus x minus 2. Now, so you need to multiply x squared by something to get x cubed. That would be x. So x times x squared, x cubed. X times negative x squared. X times negative 2, negative 2x. Subtract. So you get 0. 0 minus negative 1 gives you x squared. 0 minus negative 2 gives you positive 2x plus 0. Okay, so you need to multiply x squared by something to get x squared. That would be 1. So you get x squared minus x minus 2. Subtract. So you get 3x plus 2. So this whole thing, you can't divide it further. So it looks like that is your remainder. And the quotient is your oblique asymptote. Okay, let's sketch that. Okay, so vertical asymptote at x equals 2. At x equals negative 1. Okay. Next, now you need to sketch oblique asymptote. Y equals x plus 1. So y-intercept is 1. X-intercept is negative 1. And slope is 1. So here. Okay, so that is y equals x plus 1 line. Now put the points. So we have 0, 0. Okay. Now we will start sketching and we will try if we can do it without the factor table, okay? So if you look at the left side of the first vertical asymptote, which is x equals negative 1, so you have two options. Sketch it here or sketch it here. If you sketch it here, you have to pass through the x-axis and you don't have an x-intercept there. So looks like that cannot be done, right? Therefore, you have to draw it in this part. The middle, well, now you may need the table for here, okay? Because you don't know, right? So you can have how many possibilities? You can have this kind of a parabola opens down. You can have something like parabola opens up, or you can have something like this, like a cubic behavior in the middle, or you may have this. So there are two options to find it out. One, you can use the factor table. Two, you can use some sample values. So let's say here between the vertical asymptote and 0, between -1 and 0, you can pick a value, let's say -0.5. Yes, you can pass through the oblique asymptotes. Good question. Yes. It's like horizontal asymptotes. Oblique asymptotes can be passed through. Okay. So you can pick a value, let's say it's -0.5, sub in the function, and check if you're getting a positive value or negative value. Similarly, you can pick a value between 0 and 2, let's say 1. Okay. Let's say when you pick 1, what do you get? 1 over 1 minus 1 minus 2. So you get negative, you get a negative value here. So you know that, here I need to be negative on the negative side. Okay. And if you pick negative 0.5, check what you're getting here, right? Or you can do the factor table. But on the right side, let's look at the right side of this second vertical asymptote. Again, you have two possibilities. One is here, the other one is here. Which one is going to be? If you pick this one, right? But then you have to pass through the x-axis, but you don't have an x-intercept. So it looks like this option is gone. So you have only this. So, okay, now only the middle part. Again, I gave you the options. You can do one of them. Yeah, it is kind of a cubic behavior. You can actually kind of get it from here because see, this is giving you the x-intercept, correct? And it has an order 3 cubic. Therefore, you have a cubic behavior around that x-intercept. Okay, that is giving you kind of the clue there. So if you do this one, so you get 2, -1, 0. I'm going to do both. So you decide which one you want to do. So we have x cubed, x minus 2, x plus 1. So x cubed is going to behave like x. Again, the odd exponents will behave the same. So 0, negative, positive. X minus 2, 0 at 2, negative before, positive after. X plus 1 is 0 at -1, negative before, positive after. So you have negative, positive, negative, and positive. Okay, so if you look at x when x is less than -1, so your graph has to be below the x-axis. Okay, so this has to be that. Because if you sketch this one, you have to go to the positive side as well. Okay. Between -1 and 0, function is positive. So you have to stay above the x-axis. Okay. Between 0 and 2, you have to be in negative. The graph has to be negative. So you have to stay below the x-axis. When x is greater than 2, function has to be positive. Again, if you sketch it here, half part positive, half part negative. Okay. So therefore, you have to sketch it there. Okay. Yeah, that is the end result now.